Okie doke. Lotion on. Let's go. So we can do a bunch of stuff with structs. We can do some struct and it's called whatever. It has int x, sure, int y. So I can make a test, whatever. We'll just call it A and test B. Okay. I could then take A is now 1 and 2, and then I could make B is now 3 and 4. Oops. Okay. Then I could make B is X is still B dot X, but, or oops, sorry. Still, yeah, B dot X. But dot Y is now A dot Y. Okay, so now we'd go from being 1 to 2, or 1, 2, 3, and 4, to now 1, 2, 3, and 2. I could overload some operator action to print them. So we could do OStream reference operator insertion, taking a standard OStream reference and a this needs to be named output device, or we could just say out device, and then test is test, sure. And then we say that we're going to output test.a, or well, we could say a test.a, or oops, test.x, oops, sorry, x test.x, y test.y, and then return out device. Okay, and so what we could do is we could say, hey, A, excuse me, B, oops, and then we could say standard character output, B, new. Oh, when really I need to do something else here. And actually we're updating, yeah, we are updating B. We're gonna do an end line for each of these. Boom. There they are. Let me turn my fan on, it's too hot. Study session 2 out of 4 today. So A is 1 and 2, B is 3 and 4, but then we update B to then get A's Y. Okay. And in this case, we're not touching X, we're only touching the Y part of B. Cool. Yeah, and we can't make anything cost expression here, so we're cool. Okie doke. Oh yeah, and if I wanted, I could make A is now Y. Oops, what? Oh, A is now B, and then output A. Boom. And so instead of this being B, now we can say that this is A, and I could say that. Oh, it's raining outside. This is great. Cool. So now you have the new B, but then A is then assigned to B, the new B. Or rather, it's assigned the value of B. And I have some chunkies at the pool. Holy cow. Just pulling the window up because I like seeing when it's raining outside. It's been a while since it rained here. They got the mammoths out. Alright, let's go. Using another struct of the same type. Cool. Mm-hmm. 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 I could initialize it, I could assign it, I could do whatever. So we could say, if I wanted, oh, and in this case, well, yeah, actually, because this is the initialization, so, and we could initialize B to BA in the beginning, doesn't change anything. I could make A BB, but, oh, and I could actually do that, but that doesn't change anything. Yeah, cool, sounds good to me. Cool. We wouldn't want to do that anyways, but these are the different types of initialization, different stuff that we can do. Okie doke. This is the standard forms of initialization that we use. Copy, direct, I mean, we never touch direct. Rather than aggregate. But yeah, because there's no like matching thing. It's just saying, hey, here's an object. This object gets that object's value. And it's member-wise. This is the most commonly seen when initializing a struct with the return value of a function that returns a struct of the same type. Oh, okay. So I could pass a reference of a struct, and then it could return a reference of a struct. Stuff like that. Okay. Let me look some up real quick. By reference. And then let's go to here it is. There's only pass by value. The compiler can optimize references away, meaning that it just replaces the calls with, I guess, direct dereferences to the pointer. There are cases where this isn't possible and a reference is actually needed, meaning that it's not removed and it stores it. Well, how is it stored? It's implemented using pointers. Pass by reference is basically essentially a pass by address at a deeper level. It's just that we have something, not necessarily an object, but something is holding the address of something else. Previous lesson, that was fucking fast. The hell? It was raining for a second and then it just stopped. Previous lesson, pass by address just copies an address, which is passing the address by value. Therefore, yep, a reference is passing an address by value, so is a pointer. Well, okay. Default member initialization. We define a structure class. Yep. Oh, here comes the rain again. Oh, stormy, stormy. Hell yeah. Mm-hmm. For members not marked as static. Oh no. Might lose power. Find out. I better not. Non-static member initialization. So static one, what? Can maybe only use a default value, maybe? Hold on. As part of the type definition, okay? If they're not static, this is non-static, okay? A default member initializer. So there's none, then it's value, and then it's 2. Okay. Holy shit, that changed fast. Oh my god. Wasn't raining at all, and now it's just storm, storm, storm. Maximum. Oh no. Static members and static member initialization later. So static, it says that static and class are words that are overloaded. So static means something different, it seems like, in the context of a struct. And if we have something S1, it has an uninitialized X, a value initialized Y, probably 0, and 2 for Z. Oh my god. Is that fucking delivery guy? Oh, some guy's just running. He's got fucking shorts on and shit. Oh, that boy's cooked. And the above definition of something. Oh, can you hear that? Maybe not. Alright, doesn't matter. Yep. Oh, excuse me. Whew. X is no default value. Yep, so it's undefined if we use it as is. Value initialized for Y, and then default value 2 for Z. Cool. Every time I hear lightning, it statics a little bit. These default member initialization values will be used if we don't explicitly do it. Okay. Yeah, makes sense. I mean, these are basically like the default arguments. It's an object that has a default value. I guess the only thing we have as an example of this is probably a function parameter. So instead, it's actually the initializer for the argument, or for the initializer for this member. Yep. But we can still totally overwrite them, which is why even if these are value initialized, we can create an object and then still change it. Oh, here it comes. Oh, oh, that's so cool. 3 fucking lightning bolts just. That was sick. I haven't seen lightning in a while. Can barely see outside. Alright, oh shit. God, that's so cool. Our S1 object doesn't have an initializer. So the members of S1 are initialized back to their default value. Hold on. Fuck, I just want to sit and watch it now. Damn. I gotta wait for the next one real quick. It's all above, can't see anymore. Okay. Yep, if we create the object, those are the values. Okay? S1 has no initializer, so it gets those as default. Yep. Yep. And yep. Well, duh. Yeah. Using default member initializers, structs and classes can self-initialize even with nothing provided. Yeah, makes sense. Yeah, like you could have a base NPC guy that you paste around, and he's just got 100 health, 2 speed, and whatever, and he's got this texture. He looks like this. And you can totally overwrite it, but if you just need like some filler guys to paste all over the place, and they need to actually still be this struct, then cool, you just paste them around. You don't need to explicitly give them all this unique shit. Even though we haven't provided it. Yep. Cool. Yeah, it'd be just like a an argument in a function with a default, or a parameter in a function with a default argument. Same shit. Class template argument deduction. class template argument deduction cannot be used in non-static member initialization, meaning if it's argument deduction, it can't be used if it's, it seems like it's saying that if you have like an explicit specialization for a function, then a template won't work for it. I mean, it's going to be used, excuse me, but it's not going to deduce arguments because it's already specified, I think. We'll find out. Explicit initialization value takes precedence over default values. Yeah, makes sense, yeah. Because we can override them just like default arguments so far. Oh, still raining a little bit. Somehow it stopped already. Always take precedence over the default values. Yeah, but we could totally override them. Uninitialized to 5, value initialized to 6, and rains back. And then 2 to 7. S2 has explicit initialization values for each guy. Cool. Each member. Fuck. S2X, S2Y, and oh, let me check something. Oh, never mind. Okay. Yep. Missing ones when the default values exist. Yeah, we already said this earlier. Yep. Well, if they're missing and they already exist, then they get it. They get the default member initializer. Yep. Meaning that if it's value initialized by default, which is its default initializer, if we don't specify it, then that default initializer is what it gets. Maybe it's 0, maybe it's 1,000,000. We don't know. All right, it's in the definition. Yep. Yeah, so if we do nothing, then X gets value initialized, which is cool now, compared to not doing it. And Y and 2 get, or Y and Z get whatever their default initializers or default member initializers are, which are 0 and 2. Yeah. It's initialized with an empty list, which only overrides nothing. Actually, oh shit. Actually, that's the thing. If we had just created it, then hold. So we initialize it with an empty list, which has nothing, which means everything gets the default values that it needs. Well, X doesn't have one, so it gets one, which is 0. Y already has one, which is 0. And Z already has one, which is 2. Okay. Value initialization occurs if there's no default member initializer. Excuse me, when given an empty list. Okay. Excuse me, because it's not, oh, we are value initializing each one of these to replacing them with 0. This Picture a brace and a brace. This is an empty list. There are not 3 guys in here. There's nothing in here, which means this guy is initialized with nothing, which for a struct, he gets value initialized. This guy's already got something, value initialized. This guy's already got something too. If an aggregate is defined with an initialization list, if the explicit is used. If it's missing, hold on. If there's an explicit initializer, then we use the initializer. If there is a default, the default is used. Otherwise, it gets value. Okay. If it has no initialization list, well, yes. If it has a default guy, we use that. Otherwise, it's uninitialized. Makes sense. Always initialized in the order of declaration. So it's X, Y, Z, 1, 2, 3, etc. ABC. I guess not 1, 2, 3, but maybe if typed out. X uninitialized, Y value initialized, Z2, S1 uninitialized, 0, 2, 5, 6, 7, 0, 0, 2. The difference between no initializer and S3 is for no initializer, everything stays as is, undefined if it's uninitialized, or 0, 2. It's not value initializing anything unless it's done by default. S3 is value initializing anything that's blank. Everything else is default. S1.x, because it's undefined. Yep. Well, it will be undefined if we use it. Always provide default values, makes sense. To avoid the possibility, just give each one 0 by default at least, with some brace action, yo. Like this. We should do that. Okay. Just to show that it's 0, just like I did something yesterday with a boolean where it could have been false. It really needed to be true, so we put true. But if it could have been false, I put false in there just because. Even though it could have just been value initialized to false. We get fraction f1. Oh, hey, well, it's 0 and 1. Oh, still 0 and 1. Oh, 6 and 1. Oh, 5 and 8. Cool. Provide a default value for all members. Coolio. Default initialization versus value initialization for aggregates. And for f1, meaning it's probably better, yeah, I agree, to do value initialization, because in the case that not all, well, one, it makes it explicit that anything that's empty is now value initialized, and it also guarantees that if anything is missing, it is value initialized. Cool. I mean, it's not const. It's not like making a const in an input getter, and then you're worried that, oh no, we can't extract input to the I don't know, the fucking variable that needs to get input. No, it's fine. We just value initialize it and then explicitly give it some value. Assign it what it should be. And note that f1 is default, whereas the second is value. Yep, makes sense. The values are same because in f1, Well, because fraction has value initialization, but it isn't clear to the user that f1 is automatically safe to use because we don't necessarily know. Well, we don't know just from looking if everything is value initialized, at least if everything is initialized. Oh, that felt better. Yes, it's safer. Exactly. Yep. Yep. Preferring has one more benefit, and it's consistent with how we initialize other stuff. Makes sense. Every time we initialize something that we create, we give it some brace action. Boom. Easy peasy. For aggregates, prefer value initialization. Okay. Ooh, there's a case for non-aggregates where default is more efficient. Meaning for a non-aggregate, meaning, oh, for some static kind of crazy stuff. Default constructors and default arguments. Also the constructor being like a function inside of it. Cool. Okay, doke. So, example could be, let me test something. So we'll have Give me. We're gonna do hands of cards. We have a hand 5, which is a 5-card hand. I'm gonna leave these out of name. Well, I mean, I could. Why not? Not yet. Returning a standard string. Well, get card as string. Card. Switch on card. We could say using enum card. Case king. King. Case queen. Return queen. Case jack. Return jack. Case ace. Return ace. Case joker. return Joker. Default, default. Invalid card. Okay, and then we could have a print hand. Sure. Pretty self-explanatory, but stream reference, operator insertion, stream reference, card, card. Card 1. Ooh, it's fucking going. Yo? Oh, oops, this is a hand 5, hand. Hand.card 1. Oh, here we go. Hand.card 1. Card 2. What would be the issue here? Oh, this would need to be... The operator already needs to know how to do that. So we can do standard OStream. We can do another operator insertion, standard OStream reference, out device. This should also be called out device. Card, and then, oops, out device. And I did it again. This should also be called out device. Out device. Get card as string card. Cool. And now we can output the individual cards. Card 2, hand.card 2, card 3, hand.card 3. Oh, I guess we could just do card 4, hand.card 4, card 5, hand.card 5. Hello? What the fuck? Oh, 1, 2, 3. Wait, what? Oh, there are 2 named card 5? What the or card 4? I didn't know you could do that. And then this guy returns out device. And so does this guy return out device. Print hand of, well, teach operator insertion to print hand of 5 cards. Or we could say to print hand 5. Teach operator insertion to print card. Cool, so I could create a cards hand 5. We could say king, joker, oops, cards, card, joker, card. Oh, I could say Maybe we want to use it in this case, but maybe not. Cards, card, queen. Excuse me. I mean, I guess do I want to specialize each or specify each one? And then we could say 1, 2. Well, I mean, you get a hand of 5 cards, so. I guess Joker's rare. Excuse me. Cool. So we have my hand. Oh, duh. This should be. None of these can't be constant expression, but this can. Okay, what else? Excuse me, sorry. Oh, excuse me again. Gassed up. And if I wanted, we could do auto. Oh wait, no. Well, could I do auto? Nah, it needs to be in the scope. But we could do maybe auto here. Auto here. Standard O stream reference for the trailing type syntax. What was the purpose here? And then we can leave these to be initialized as nothing. King, because king is the default value. So we could leave. We could make empty. We could make it a bunch of standard optionals. Because it optionally has a card. What if we did that? Now we're gonna have issues though. Because this is not right. We need to. Oh, actually, this is what we do. We say. Guess we could check if it's empty. Hand is empty. If none of them. We'll check one thing. If. What's the easiest way to check if this is empty? I mean, I guess I have to evaluate every single one of these, right? If not hand one, hold on. If not hand dot card one, and not hand dot card two, and well, and at least this way it short circuits, and not hand dot card three, and not hand dot card four, and not hand dot card five. Hand is empty. And then we return out device. But otherwise, check if hand is empty. Otherwise, we do if hand.card1 hand.card1. I think that's cool. Oh, well, I can just dereference it like that. And then I could do the same thing for the rest. Two, 2, 2, 2. Oh, oops. 3, 4, 5, 5, 4, 3, 2. Printing hand. Should really be. Well, the one thing is to make it so that if you have 5 cards and you remove your third one, then the next guy should become your third and fourth. Maybe this is probably a way around that. I just don't know it right now. Card 1. We could do that, and then we could just do card 5, 4, 3, 2. Yep, we only have those cards. Oops. But in this case, if I instead did... And how could I do it? I could initialize it, or I could do different things. So we could do dot card 1, and then put this guy in braces. What the fuck? What are you doing? I could do parentheses. I could do braces. What is that? It puts the whole thing? So if I highlight any of this, it puts the whole line. Oh, it's annoying. I guess I could do that. And then dot card 2. Or we could do dot card 4. And then dot card 5 is this. Because queen isn't enough. This is an enum value. We need to say that an enum is not what this struct is storing. It is storing standard optionals. So what we need to do is pass it the value to the optional, which can hold the value. And now we can output it, and it'll say 1, 4, and 5. And I really don't want to go boom, boom, like that. But I'm going to try real quick. Boom. Oh, what the hell? Holy shit, strobe. Boom. Boom. Okay, same thing. But now what if we say my hand? And what if we do the same shit? So we just say my hand. It's not happy here. We could say equals to assign it, but in this case, it's thinking about arguments. An initializer list is unexpected. Probably because it's already been initialized. Wait, what? Why is it cool with this? Okay, I was gonna say it shouldn't be. But now I can assign it. If I want to keep these cards to be the same, which is kind of annoying, I mean, we could say card 5, my hand.card 5. I think I can do braces either way. So we could do card 4, my hand.card 4. And then we could do, oops, well, my hand.card 4, or .card 1. But then we could say dot card 3 is now cards card king. Boop. So it seems like I can reinitialize them. Or like use this. I can use braces to assign value to existing guys inside this struct now. I don't have to do assignment operator, which is interesting. It's the same as if I was able to do like in x is 5, but then I did x is 6 now. Like, no good. Can't do it. It's already been initialized. So in this case, we've added king as card 3. So it was 1 4 5, now it's 1 3 4 5. Okay. An employee represented by 3 loose variables. Bop bop bop. Yeah, it's trash. Oh, but now we could just pass the whole thing. So yeah, so we could do like oh, we could have a count to check how many of each card is in the hand and then determine whether a hand is good or not. I don't know how I could iterate through the cards, so that would be cool. Instead of having to check them all each, but how you make a function that's called void print kings, and I could pass it a cards and 5 reference, and really I could pass it called hand. I'm curious what the 2 issues it had were, and we could make this const so we can't fuck with it. Hand is unreferenced. What was it? What were the issues it was having before? Here we go. Expected a definition and the function type. Oh, because now it's thinking that this is like some big ass crazy function. Makes sense. And it's thinking that the int should have a semicolon. It shouldn't be together. On 2 hands, it's like, well, this is a weird combination. And then on this other hand, it's saying, hey, that shouldn't be together. Print kings, and we could say, I mean, I really wish I could just loop through the 5 cards. But we could say int num kings. And we could say if hand.card1. Oh, hold. Why am I unable to access that? I'm not sure yet. That's a hand 5. Oh. Yeah, it just doesn't like that because it's already not happy about this. So it's not going to give me IntelliSense anymore. Yeah, it's expecting an actual condition here. If hand.card1 exists and hand.card1 is card king, increment num kings, and then we can do the same thing 1 2 3 4 5, and then return num kings. This is the same shit, but we could do, oh well, next we could say, yeah, whatever, kings, number of kings, num kings. Cool, but now we could say 5 4 3 2 2 3 4 oops 4 5. And now I could call it with, we have one king in this case. And let's say jokers aren't wild. Let's say jokers are their own unique card. We could output, or we could just call print kings and pass it my hand. One king. But then we could say my hand is now, I want to change multiple values. Or we could say my hand dot card 2 is now cards card king. Print kings, my hand. Yeah, so I guess that's what you want to say. If there are multiple things changing, then we can do this. Otherwise, we could just go in here and change one card. And now kings are 2. Cool. So we can pass them. But then I can make another one and I call it cards hand 5. Her hand, another hand. And it's initialized to be get or copy hand. My hand. Okay, and then we have another guy here, and it returns. Hey, const cards hand 5 reference, and it's called get copy hand, and it takes, well, let's just say it treats it const cards hand 5 reference hand, and we return hand. And now we could say output her hand, or we could say her hand is now oh, and this should be number of kings. What's happening here? Number of kings 2. It's not going to the next line? Oh, it is. It's just not, it's not entering 2 lines between it. When we print the hand, how's it doing it? It's saying, oh, if multiple are empty, then it just ends the line. But that's only if it's valid. If it's not, then it shouldn't even be printing this anyways. It's like we print this, and then we end the line. Well, actually, yeah, we do queen. So let's say card 5 is valid. And then we end the line. Oh, but the thing is this. I was doing this. I was outputting, I was putting an extra thing after the hand. Just give me, you got my hand, you got my new hand, you got the number of kings in the hand, now there's a new number of kings, and then her hand. Some girl copied my hand with her fucking skill ability or something. Oh, but hold on. My hand has, let's see. We print kings. Oh yeah, and then we print kings, but we're not printing the hand. Okay. the hand is this, and it was copying. All right, I was wondering what was going on. It should be getting the exact values of this object, and it was. I was like, at first I saw, before that, I should have just done bop. It looked like her hand was for some reason different. Like it had a card too. Where's it getting a card two from? I get king is default value, but actually, and this is actually it's empty by default. She shouldn't be, but it's just because I put that card in the hand. So now we do have a 1, 3, a 4, and a 5 plus a 2. We have 5 cards in the hand. And in this case, we're passing a reference. We're passing the pointer to the guy, and then it returns a pointer. And so it's initializing the values directly at memory. It's looking, hey, here's his hand, my hand, and then here's her hand. Copy the shit over. No separate copies, just the one assignment. Yeah, this would be trash. Now we could just pass a reference to it, a const reference to it, because the struct is an L value, so we can just well, actually, even if it was an R value, but in this case, it's an L value, so we can pass it via reference or via address. If we pass an address to it, do I have to dereference it and then do the dot? I wonder how that would work. How would this go? Let's find out. This is a pointer to a const. Oh, here we go. And this needs to be the address of my hand. And then if we said a pointer to cards hand 5, pointer, hand pointer, and it gets the address of my hand, I could then say dereference hand p dot card 1. Gotcha, because it's dereferenced hand p dot card 1. Oh, I like that. Cool. Let me do some push-ups real quick. I'm fucking energized right now. I'm maxed out, dude. Feeling good. Grateful to be alive. Happy for everything. Look at this rain, man. It's fucking beautiful. Fantastic. Full. Kind of easy. We'll do one more. Oh, I had to hold my breath. Oh. Now I need to get the feet closer. Let's do another. Oh shit, it's hard. The feet closer is so much harder. Because one is I do push-ups from here, so now I have to like, I don't know. The feet closer is really tough because it makes you go from instead of like this, you put your feet out and it like, I don't know, your body just moves in a weird way. Okay. Pass this employee to a function. We pass 3 variables. Oh, fuck that. Ah, hell no. Instead, we just say, boom, boom, done. Create employee as default values. Initialize it here. Boom. And then, boom, print him. Pass him via const reference. Is this German? Fuck yeah. It's still terrible. Because then we say, oh, the employee is this. Because we also need, well, I guess we have the ID, but employee ID, age, wage. Getting input from an entire employee from text and initializing a struct with it, it's kind of complex. Because you have to initialize it with so many, well, I guess you could just teach, oh yeah, you would do character input. So you would literally just do standard character input, extract to a value initialized struct to get the user struct. But you would have to teach, or in that input, you would have to have, you could have it call different functions to get different values, or you could have it do the whole thing. And you need different while loops. Because while true, you need to make sure that you get a valid ID, and so that anytime an invalid ID is entered, you continue getting just the ID. And then after, yeah, and you don't want one loop, because if you get the valid ID, but then you get the valid age, but then the age is invalid, you don't want to go back to the start and then get the ID again. And you don't want variables to check that each time. I'd rather just have a loop for the ID. Okay, we got a good ID. Continue. Or, well, return. And then boom, then return, boom. So I guess separate functions, like get employee ID, get this, get this, get this. But it's also a lot of calls, so something like that. I'm not sure. I'm not fully sure, but I think it seems like it could get kind of long. Actually, it's pretty easy if it's just integers and shit like that. But plus the name, plus this, plus that. And then when you add in enums can get a little bit more, but it's not that crazy. I'll probably have to do that for my little card project. Yep. Yeah, instead of passing the same struct object that automatically has the new little guy in there. You would just have to update the functions to actually use it or not use it, so it wouldn't actually mess anything up. Yep. Typically by const reference, yeah, makes sense. Because we're not manipulating them. But maybe we need to. Maybe you apply damage or something like this. Or maybe you just set the employees thing, so could go either way, honestly. Different ways to do stuff. Like you could pass the employee to a function and then update the employee there to give him like a debuff or something. Or you could just set the employee's state, debuff state, to be the return value of the debuff. So you could go either way. And honestly, the reference might even be cheaper because you're just passing an address to the. Oh, well, I guess not because there's the value. It's in memory, and then boom, and then maybe depend. It might depend, but value is actually probably better there. We got main. We got Joe's information. Cool. We print employee Joe. Okay, we got Joe, and he's got what? An ID, an age, and a wage. ID and an age and a wage for Frank. Print Joe. End line. Print Frank. Where's the end line? What already ends the line, so it's fine. He's just spacing it out one between. Yep, and we're passing it by cross reference, and in this case, it's just the void that prints it all. So we don't have to do it each time. Passing the entire struct object. Only one parameter. That's beautiful. Yep. Passing structs by value. When would we ever do that? Oh, apparently if it's cheap. It said in Perplexity last night if it was like a little tiny thing, like 2 integers for a struct. Like this struct is probably fine. It's cheap. But if it's big, standard string or something, I don't know how much more expensive that is, but apparently more. And assuming 1 byte per character. Bro, how long is this? This is just unique the whole way. It's only 46? I've been looping it and I haven't felt like anything's been repeated. Passing temporary structs, huh? One to create Joe and one to use Joe. Meaning instead of just printing and then passing in the information, huh? Yeah, but we probably want Joe to exist somewhere in the system. Instead we're just printing, yeah. Oh. Because the employee can deduce that, hey, you're passing an ID or an int and a double. That's an employee. So it calls print employee. But you could also just say employee and then leave it unnamed. Excuse me. Yeah, I would agree with specifying it like that, because otherwise we could have, I don't know, anything that uses 3 numbers like that easily. Agreed. And maybe I'm disallowing calls like that. Makes sense. We could do like we could do a struct and just call it a list, and then we say int x, int y, int z. Void compare list. And then we have list list A, and then list B. And then we could say in comparison, and we could say if a dot x is greater than if a's x is greater than b's x, then plus plus comparison. Else if a dot x is less than b dot x, then minus comparison, and then else nothing. But then we could also have another for if a dot y is greater than b dot y, plus comparison because it's in a's favor, and then else if a dot y is less than b dot y, minus comparison, and then else nothing. And then we can say if comparison is greater than 0, output list A is greater, else if comparison is less than 0, list B is greater, and then else list A and B are equal. Is this even a good way of doing it? Or, I mean, I guess we could say this is one way. This might be a terrible way. I don't know. And then we just do compare lists. And then we say list 1, 3, 4, and 3. List. Oh, wait, hold on. 3. List 5, 3, and 7. Uh-oh, hold. What the fuck is that? Where are you having an issue? Oops. And in this case, we are totally passing by value. But, well, I guess we could... I don't know. Did we get it? We could get a const reference to it, maybe. Is this possible? Const list reference? Oh shit, I guess so, huh? And if I get just a list reference, it's an R value, huh? Yep. What? Because 1 is less than 5, but 4 is greater than 3. Oh, but then... Oh, I didn't compare z. Hello? Z, 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 and z. B is greater. Yeah. And then we could say... Do I even need the else? I guess not. We could just say, hey, if it's this, otherwise don't touch it. If it's this, alright. Compare x's. Compare y's. Compare z's. Output comparison. 0 equals tie. Means tie. Cool. Something like that. If I could do a const reference to pass by temporary. Oh yeah, here it is. Here's an example. We're doing const reference. Yeah. Here it is. R value. All right, let's read the rest. Talk more about temporary class objects, or temporary type objects, class type temporary objects, and conversions later. Okay. They're created and initialized at the point of definition, and destroyed at the end of the full expression. Yeah, it's the same. Bro, it's an R value. Hello. An evaluation of a temporary object is an R value expression. Can only be used in places where R values are accepted. Yeah, because we can't have a reference to an R value, but we can't have a const reference to it. Yep, exactly. Boom. Pop, pop. Yep. 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 Case where we have a function that needs to return a point in 3D dimensional Cartesian space. Boom, boom, boom. Or boom, boom, boom. Yep. Well, we could return the struct boy. Question is, how do we make him last? I mean, we could do return by value in this case. Uh-oh. We got a struct, and it returns a struct. Uh-oh. I mean, maybe it's okay because it's 3 doubles. Maybe that's cheap. And it creates a temp. I mean, we could just say get 0 point return point 3D 0.0.0 blah blah blah. And then in this case, we're creating 0 get 0 point, and then if this, or if this, and this, and this. Cool. Cool. Structs define functions that return by value is to not return a dangling reference. Yeah, unless we made a static one. But then that's the only one we ever get, I think, right? Yeah. Create a new one. Yeah, there it is, just like that. Yeah, there's no point in naming it just to destroy it. Yep. So it is constructed assigned to whatever it needs, or whatever needs it, and then destroyed. Yeah. Oh, and that's an anonymous object? Okay. Deducing the return type. So we could just do this. We can even omit it. I don't know about that, bucko. Oh, well, and if the default values are 0, well, and actually, even if they weren't, well, yeah, the values would need to be 0 by default or empty. So value initialized with 0, or default initialized. Because if we do a list here, oh, well, I guess it would create a temporary initialize like that, huh? Yeah, but it would still get the default values of a point 3D. And if a point 3D is normally 9, 7, and 2, because that's the corner of the map and everything has to start from the corner of the map out, then you return to the corner of the map, bucko. Right? We could initialize x to be get point dot x. Exactly. So in the instance with a 0 point, you better assume that a point 3D is value initialized or uninitialized, bucko. Or explicitly given 0. Because if you initialize it with nothing, you better hope those default values don't change, buddy. Something like that. An implicit conversion to it, because it's saying, hey, we got this, this, and this. That's an initializer list, which can be implicitly converted, I guess numerically converted. I'm not really sure. Or I guess we call it a user conversion, a user-defined conversion. Because what do you even call it? The members, the parameters, the arguments match the data members of a user of a program defined type. Not necessarily. This assumes that point 3D was initialized properly. Oh, and then a quiz. Nice. Structs are useful. Classes build directly on top of these. Oh shit. Okay. A website. We need a struct for the website. Ads. How many ads? What percent were clicked? And the earnings per ad. Okay. Boom, boom, boom. Pass it to print. Okay, so we're gonna do struct, let's say website stats. We're gonna say int ads watched today, double percent ads or user, well, percent ads clicked by users, something like that. And then double earnings per ad. Okay. I could say, or yeah, this could be just like a calculator. Meaning temporary stuff. Oops. Okay, and now we can have, hey website, tell me how much I would make if 100 ads got watched today and 50% of people clicked on them and I make $50 an ad, huh? Uh-oh, hold. Oh! That's not correct. That is not a correct call. It is expecting one argument with multiple things in it. This needs to be a bop. No, please. All right, well, I could do that. Are you fucking me? What are you doing? And then we can make it, what do we call it? It's a website stats. There it is. And we print it like that. And we get 25 big boys. Bop. Can't make this guy const expression because we're doing some character output stuff here, which is only at runtime. Write a program that allows you to enter 3 pieces of data? You mean standard character input and shit? What are you talking about? Oh, shit. I guess so. Store it and pass it. So how do we want to do this? Do we do a function call to get this int, another to get this, and another to get this? Or do we do one that yields a struct and returns it? I don't know about that. I'd rather, because the struct could be expensive. I'd rather... this is also a lot of shit, though. We could say... Fuck. Double or int. Alright, whatever. I'll continue this in a minute. That's it for time. Cool. Alright, that's it for today. Oh, well, that's 2 out of 4 today.